everyone. My name is Will England. I work for Cherokee County Water and Sewage Authority in the Environmental Affairs Office. I'm here today to talk to you about the water and sewage process. So how water gets to you at your home, at your school, at your business, and what happens after you get finished with it, when you flush the toilet, when you take a shower, when you put clothes in the washing machine, where does that water go? So this is all in celebration of Drinking Water Week. And Drinking Water Week happens once a year, and it focuses on the vitality, the importance of water in our society. And this dates back to pre-Roman times when they built aqueducts in order to get water from place to place. So in order to do that, I've got an Enviroscape here, and this Enviroscape is going to allow me to demonstrate how water is pulled out of the river, what happens from point A to point B, point B being your home, and when you get finished with it, where does it go, and how does it get returned back into the environment. In our Enviroscape that we've got here, I've got a city, we've got some business buildings, I've got a water plant, a water tower, a factory here, a wastewater plant, a farm, a subdivision, a school, and a hotel over here. So here's the hotel. Alright, to begin our process, we're going to start out with the water plant. And this body of water that you see flowing around the Enviroscape is the Etowah River, which is the largest river in Cherokee County. And it flows to Lake Altoona down here at the bottom of the Enviroscape. So to begin our process, to begin our journey with the water, we're going to pull water out of the Etowah River, which we do at our water plant in Ball Ground. And our water plant in Ball Ground is called the Etowah River Water Facility. And it has the capacity, it has a permit, we get a permit from the state of Georgia in order to withdraw and treat 38 million gallons of water per day. But on average, we treat 18 million gallons of water per day. So we're going to pull water out of the river, and in real life we have a settling pond. And in the settling pond, it's going to allow all the settleable solids to settle out. So as the name implies, settleable solids are the heaviest solids in water. There's three different types of solids in water. We have settleable, we have suspended, and colloidal. So settleable being the largest, suspended being the next biggest, and then colloidal being the fine little particles that you can't really see with the naked eye. And we talk about solids in the way that you would typically be able to relate to those is in a heavy rain event. When it rains really hard, really fast, the water in the rivers or creeks or the water running down a drainage ditch is going to be really dark brown, and that's going to indicate a lot of solids in the water. So that's what happens. We want all those solids to come out of the process, and we remove them at different points in the water process. So we're pulling water out, and normally, as I said, it would go to a settling pond where all the settleable solids would go. But since we don't have that on this Enviroscape, we're going to start out with the first basin. And in the first basin, we're going to add air to the water. I'm going to indicate that by blowing bubbles in there. And the reason we add air to the water is to improve the taste and to improve the smell of the water. We want to make it just as pleasant to drink as possible. From there, it's going to go on to basin number 2. And in basin number 2, the way that we remove the suspended solids and the colloidal solids is we're going to add a coagulant. So a coagulant is a chemical. The one we use in particular is called PAC, which is polyaluminum chloride. That's its acronym. We add PAC to the water, and what it does is it causes all of those colloidal and suspended solids to stick together. And once they start sticking together, they form a mass. We call that flocculation. So coagulation is when we add the coagulant, flocculation is when they all stick together, and sedimentation when they settle to the bottom of a tank. And that's the way that we remove the solids from the system. It's going to go from there to the filter. And we have large filters that are able to remove solids and different impurities down to just really small subatomic, in some cases, matter. So we have our filter. You can see the orange That's where it picked up the coagulant, so it wasn't able to move on to the next stage. After that, we're going to add chlorine. And the reason we add chlorine to our water is because it prevents the growth of bacteria and pathogenic viruses. So we want to make sure that our water is virus-free and bacteria-free when it comes to your home. And this is a technique that's been around since the early 1900s. So we're going to add chlorine to our water, and from there, we're going to send it to a water tower. You probably noticed the water towers out in our system. And the water towers, they serve a couple of functions. The first function is they're elevated in order to provide extra PSI. It adds pressure to our line, or pounds per square inch, so it allows our lines to be further under pressure. We also use pumps for that purpose. The second thing that water towers do for us is they are an elevated reservoir of water in times of high demand. So a high demand time would be when you first get up in the morning and you get ready to go to your work, or to go to school, or to go to your business, your place of employment. You're going to get up, you're going to brush your teeth, you're going to take a shower, maybe make some breakfast, and a lot of other people do the same thing around the same time. So around the hours of 5:30 till 8 o'clock in the morning would be considered a high demand time. The second time of day that would be a high demand time would be when you get home from your place of employment or your school or whatever. So you get home, you get dinner ready, you put a load of laundry in, you wash dishes. There's all kind of things that you use water for, and so that's when a lot of people are all using water all at the same time, which is why we call it a high demand time. If everyone turned on their water all at the same time, it would cause our lines to go dry. So the water towers, they provide supplemental flow in those high demand times. So they fill up during low demand, so around midnight, mid-afternoon when no one's using the water. They fill the water up in the tanks and the towers, and then they allow water to be used in high demand times. So from that point, I'll move the road, and you can see the infrastructure that's underneath the road, which is, our lines are normally beside the road in a lot of cases, but in some places it's underneath. All right, from our water towers, the water is going to flow to the businesses over here and to the homes and neighborhood over on this side. And once it gets to that point, some of the activities I mentioned earlier, you're washing your hands, you're going to the restroom, at home you're washing clothes, all different kinds of uses that you use water for. When you get finished with it, it's got to go somewhere. And so once it goes down that drain, we refer to it as wastewater or sewage. That's going to be indicated by the brown water here. And I want you to notice that the brown water is in a completely different line than the drinking water. We keep our water lines and our sewage lines away from one another so there's no cross-contamination. There's no risk of getting sick from our wastewater. So the same thing happens over here at your home. You'll see those lines run together. Over here at the factory, they're going to be flushing their toilets also. And now since they're a factory, they have a product. They have something they produce. In Cherokee County, the main industrial user that we have, an industrial user would be something that has a different type of effluent, a different type of waste than what's characterized as just normal going to the bathroom, taking showers, things like that. So we have a chicken plant, which is our main industrial user, and typically their waste is higher in ammonia than some of the other, just your normal waste. And that has to be pre-treated before it ever reaches to the regular sewage. If not, it's going to adversely, or it's going to negatively impact what happens at the wastewater plant. So in this particular example, they're making use of a wetland to be able to pre-treat their water, and you'll notice it's sucking in all the solids all before the water is able to escape. So it's able to retain a lot of water before it goes onto the lines. Alright, water is going to continue down through our wastewater lines. And I want you to notice as we're going down through here, there's another line right here. And this line is what's called the stormwater line. And stormwater being completely separate from the sewage line. In some places, in a lot of older cities, they have what's called a combined sewer system, which means they had them both together and they both went to a wastewater plant, which caused a great deal of variation. If you had a large rain event, if you had a lot of water, then the amount of influent, the amount of water coming into the plant is going to be much higher than in a normal event or a drought even. So in most cities now, they have them separated. So what we have is referred to as a sanitary sewer, which means the only thing going to our sewer plant is sewage water. And everything that's stormwater, everything when it rains that's running off the parking lots and off the tops of your roofs and things like that, it all goes to normally a retention or a detention pond before it goes to the closest water body. Now over here at the wastewater plant, I'll remove the wastewater cap. And the first thing you're going to notice is that water is going to flow to this screen. And this screen is going to filter out things like flushable wipes. It's going to filter out things like maybe your brother or sister's little toy Hot Wheel car that got flushed down the toilet by accident, or your parents' any keys or rings or things that shouldn't belong to the toilet to begin with. So it's going to filter out all those things so they don't cause a problem in our system. Pumps, they can become clogged and they can get torn up if there's something that's not supposed to be in there, if it gets in there by accident, so it breaks the pump. So we have a filter in place to remove those things before it goes to the primary clarifier. And the primary clarifier, so primary meaning first, is where all the settlable solids are going to get removed first. So all the heavy things that I was talking about over here in the water side, all the heavy solids are going to settle out in the primary clarifier, and all the cleaner water, the clear water, is going to flow over a set of weirs. And a weir looks kind of like a letter V, and it's going to keep solids behind that V, and all the clear water is going to be able to pass over the weir so that so the water in the second tank is much cleaner. So that's going to be our secondary aeration tank. And what happens, by the name implies, in the aeration tank is where we provide air. We use microorganisms. It's a biological process that we treat wastewater with, and we use microorganisms, or really small organisms, to break down things like different forms of nitrogen, like ammonia and nitrite and nitrate, to take up things like phosphorus. So we want all those things broken down to its most simplified and most stabilized form before it goes to the next portion of the process. So we're going to provide our air for our organisms that are in there. And in this tank, it's going to go through a series of stages. So the first stage, the water comes in and it gets mixed. We want to make sure it's a good, thorough mix of influent being the raw sewage, and we want whatever's already in there to get mixed well, so our microorganisms, so they can take up all the nutrients. Then the next stage, we're going to add air, so we're going to allow those bugs to just go crazy and start taking up some of these things. Once that gets completed, then it's going to go through a settle phase. So all the heavy stuff, all the heavier solids are going to settle to the bottom of the tank, and all the clearer water is going to be decanted or removed off the top. And that's going to go from here to the secondary clarifier. And the secondary clarifier, you'll notice, is much cleaner looking. It's less turbid than what's happening over here in this tank. One thing I want to point out before I leave this tank is that we have all the solids that have settled out to the bottom. We've got to do something with them. We can't leave them there, or else they accumulate to the point that it clogs up and it fills our tank. So we remove those once they get too heavy, too thick, and we send them over here to a digester where they get further stabilized. All the bugs They're allowed to end their life. These are the older bugs, and they have already eaten up all the things that they can. And once they get stabilized, then they get sent to, in some cases, an incinerator where they get burned, and then they become almost like a powder. And in other cases, the way that we do our waste, our sludge, is we mix them with a chemical that allows them to stick together, and we put them in a press and we squeeze all the water out that we can, and then it's almost like a Play-Doh consistency, and then it gets sent off and it gets mixed with peanut shells or peanut hulls, and it gets sold as fertilizer. So going back to our secondary clarifier, this is the stage. We still have suspended solids and we still have colloidal solids that are still in the process, and we need to make sure we get those out. So similar to the water treatment, we're going to add our coagulant to the secondary clarifier. It's going to allow it to coagulate and then flocculate, so all the solids are sticking together. They're going to settle out, and then from that point, it's going to go on over here to the chlorination tank. And the chlorination tank is in the process in order to kill all the pathogenic bacteria, all the viruses that are in the wastewater, because we don't want to send that straight out to a stream. It would harm the organisms and fish and things that live out there in the stream. So we add chlorine to the water to kill all those things, but before we can send it further, we need to dechlorinate. So we're going to add a chemical called sodium thiosulfate to dissipate, to keep all the chlorine from being able to get to the next stage. And then we release that from here onto the Etowah River. Now, other alternatives to disinfecting by chlorine is by the use of ozone or the use of UV light. So we use both of those things to stunt the growth, to prevent bacteria from being able to replicate. And by doing so, they die pretty quickly in the system since they can't replicate. Alright, so there's our wastewater and water portion of the system if you're within our infrastructure, if you're within our lines. There's some people, however, that live in a more rural area that don't have access to these areas or access to these amenities. And if you happen to be in that category, then you're probably going to be on a well and on a sewer tank, or a sewer septic tank, I'm sorry. So for that, I'll move over here to the farm area, the rural area. If you're on a well, an artesian well in particular, you're probably going to have a pump, and it's going to allow you to pump the water from that well down below and get your water for drinking and bathing and washing dishes and washing clothes. And so there's your water there. And the same as with any other system, when you get finished with it, it's got to go somewhere. You flush your toilet, your dishwasher drains. Alright, I'm going to move the house for this portion. You can see the waste is going out, and it's going to go to a septic tank. And the septic tank is another form of wastewater treatment. It's a concrete tank that allows anaerobic bacteria, so anaerobic meaning they don't need air, compared to aerobic that happened over here. So these anaerobic bacteria are going to break down the same phosphorus, the same nitrogen, and they're going to stabilize the waste. Once all that settles down to the bottom and you have the accumulation of solids in there, a lot of times you'll get a company to come out and pump the solids, and they'll take those to the wastewater plant. And all the liquid is going to be dispersed across your yard in what's called a fill lines. Then the fill lines, they allow all that liquid to go out in your yard so you don't have an erosion problem from all the liquids coming out of your septic. So even though the two different systems, they've got some similarities and they've got some differences, these are both a crucial aspect of how we are able to live our daily lives, and they play a crucial role in our society. So during this Drinking Water Week, I'd like for you to be mindful of how the water gets to you, and we need to be thankful that that system's in place and that it's constantly changing and getting better in order to meet the needs of the community. So happy Drinking Water Week from us at the CCWSA. Thank you.